Hello everyone, welcome back to Tech 10. So in our previous video in the linear algebra series, we saw how to solve a system of equations where there were two unknowns. So today we'll go a step further and see how we could solve a system of equations where there are three unknowns. And we need to find the values for x, y, and z. And our approach in this case, what we want to try to do is pick any two equations and try to eliminate one variable. And that will be the first step that we want to do. So let's get started by doing that. So here, if you look at these three equations, I would say that I would pick equation 1 and 2 to begin with. Why? Because if you notice that the coefficient of x in equation 1 and the coefficient of x in equation 2 are the same. So there is little less amount of work that we need to do over there. So before we begin when solving such kind of problems, we want to analyze the equations that have been given to us. If there are any two equations where the coefficients of a variable is same, then it would be helpful if we pick those two equations to solve first. So that's exactly what we're doing here. So I'm going to write these two equations separately. So we have x plus y plus z is equal to 2 and x plus 2y plus 3z is equal to 5. And here, since the coefficient of x is same, we can try to subtract one equation from the other. And the way what we could do is flip the signs of one of the equations and then just add the two equations. So that's what I would want to do here. So if I flip the signs of the second equation, the positive x is going to become negative x, positive 2y is going to become negative 2y, positive 3z is going to become negative 3z, and positive 5 is going to become negative 5. So if I go ahead and add the equations 1 and 2, so let me write that. This is equation 1 and this is equation 2. If I add these two, x and negative x get cancelled out, and y minus 2y is going to be negative y, z minus 3z is going to be negative 2z, and 2 minus 5 is going to be negative 3. So this is what we have. Let's mark this as equation number 4. So now that we have this, what we can do is go back and pick out two other equations again, either 1 and 3 or 2 and 3, and follow the same step. That is, try to eliminate one variable. So let's begin by this time by trying equation 2 and 3. So let's go ahead and do that. So if you see here, we have, so let me just say that this is step 1 and then here's step 2, where we're going to solve the equations 2 and 3. So that's going to be x plus 2y plus 3z is equal to 5. And again, if we notice here, there are no variables in the equation 2 and 3 which have a common coefficient. So what we can do is, since in the previous step 1 we have eliminated x, we can try to do the same thing. That's what we want to do. So that when we remove x from the equations 2 and 3, we get another equation which is going to have just the variables y and z. And then we can use that equation along with equation 4 to find either y or z. That's what we're going to try to do. So in order to do that, I need to have the coefficient of the variable x in 2 match the coefficient of the variable x in equation 3. So I need to multiply equation 2 by 4. That's what I'm going to do now. So if I multiply this by 4, I will get 4 times x plus 4 times 2y plus 4 times 3z is equal to 4 times 5. That is 4x plus 8y plus 12z is equal to 20. And my equation 3 is 4x plus 7y plus 56z is equal to 28. So again, I'll follow the process of flipping the signs of the latter equation and then just adding the two of them. So that's going to make positive 4x become negative 4x, positive 7y become negative 7y, positive 56z become negative 56z, and positive 28 become negative 28. And following the same process, adding these two is going to cancel out each other. 8y minus 7y is just y. 12z minus 56z is going to be 44z minus 8. This is our equation 5. So if you notice here, like I said before, my equation number 4 and equation number 5 have two variables. This is along the same lines as the system of equation with two unknowns. So here we can try to solve for x or z. So let's write them out separately. This is our step 3. And our equation 4 is negative y negative 2z is equal to negative 3. And our equation 5 is y negative 44z and negative 8. So if you, as it's seen here, I don't have to multiply any of the equations with another coefficient, because I see that the coefficient of y in equation 4 and 5 is the same. And I just have to add it because the signs are also different. So when I add them, positive y and negative y get cancelled out, and then these get added. So that's 46z, and then you add these two, which is 11, and z is going to be negative 11 over negative 46, which is z is equal to 11 over 46. So now that we have the value of z, we can substitute it in one of the equations, 4 or 5, to find the value of y, which is what our fourth step is going to be. So let's take up the equation number 4, which is negative y, negative 2, and z's value is 11 over 46. So that's 11 over 46 and negative 3. So let's just flip the y and the negative 3. So that's going to be 3 minus 2 times, or we could just cancel out 2 and 46. So that's going to be 2 times and 3 times. So 3 minus 11 over 23 is equal to y. And the common factor here is going to be, common denominator is going to be 23, and here this is 1. So 3 times 23 is 69, minus 23 times 1 is 23, 11 times 1 is 11, is equal to y. So if I subtract this, we get a 58 over 23 as the value of y. Okay, yeah. So now that we have 2 out of the 3 variables value. So using the value of y and y from step 4 and z from step 3, we can substitute them in the first original equation, which is here, and find out the value for x, which is what I'm going to do in step 5. So our first original equation was x plus y plus z is equal to, and I don't know the value of x yet, but I know the value of y, which is 58 over 23, and the value of z is 11 over 46. That's 2. So let's just get a common factor here. If you see 23 times 2 is 46, so I'll put 46 as the common denominator. So 23 times 2 is 46, and 58 times 2 is gonna be, and 11 and 2. So x is going to be 127 over 46 is equal to 2. So x is gonna be 2 minus 127 over 46. 46 is the common denominator, and which is negative 35 over 46. So that's the value of x. So we have the value of x is equal to negative 35 over 46, y is equal to 58 over 23, if I'm not wrong, yeah, and z is 11 over 46. Z is 11 over 46. So in our original equation, that is 1, just this is like the confirmation step. X plus y plus z is equal to 2. What we need, we know that the values of x, y, and z are correct when LHS is going to be equal to RHS. So let's see what LHS is. It's going to be negative 35 over 46 plus 58 over 23 plus 11 over 46. So the common denominator is 46. So that, and that is negative 35 plus 127 over 46, which is 92 over 46. 46 times 2 is 92. So, which is nothing but our RHS. So the values that we have found for x, y, and z are correct. I will see you in the next video. Thanks for watching. Hope you all are liking this simple series. See you again.